Hi students, in this video we are going to learn about EMF equation of single phase transformer. In single phase transformer we are having primary winding and secondary winding. Under primary winding we are giving AC supply, that is denoted as V1. The current flow in the primary winding is denoted as I1. And the number of turns in the primary winding is N1 and the induced EMF in the primary winding is E1. On the secondary side, the number of turns in the secondary winding is N2 and the induced EMF is E2. The current flow in the secondary winding is I2. As I said in the previous video, here when we are giving the AC supply to the primary winding, the alternating flux will be produced in the primary side and this alternating flux will be flown through the transformer core and it will cut the secondary winding and the current flow in the secondary winding will be I2. So here when the alternating flux cuts the secondary winding, the EMF is induced. That EMF is denoted as E2. So here to learn the EMF equation of single phase transformer, we need to know the equation of Faraday's law. Okay. So according to Faraday's law, induced EMF E is directly proportional to d phi by dt. That is, induced EMF E is directly proportional to change of flux. That is d phi by dt. So here when we are giving the AC supply, the alternating flux cuts the secondary winding. So that I have drawn the alternating flux here. Alternating flux is denoted as phi and the maximum flux is denoted as phi m. So for one cycle, time is denoted as t and for half cycle it is denoted as t by 2 and for maximum flux phi m, when it reaches the maximum flux, the time is t by 4. Okay, so here now according to Faraday's law, the induced EMF E is directly proportional to rate of change of flux. So in this we need to find the value of d phi and the value of dt. Okay, so change of flux can be calculated by maximum flux value minus minimum flux value. Okay, so here we are having the maximum flux value as phi m, right? Phi m and minimum value as 0. So therefore d phi is equal to phi m. And at maximum flux the time will be at maximum, here this is phi m. This is the maximum value and the time value is t by 4. So therefore t by 4. We all know the value of time is 1 by f. So we can substitute here. Therefore dt is equal to 1 by 4 f. Okay. Now we can substitute the value of d phi and dt in the Faraday's law. Therefore E, we have already seen E is directly proportional to d phi by dt. To change this proportionality, we need a constant. I am taking it as a constant as 1. So therefore E is equal to 1 into d phi by dt. Therefore E is equal to d phi by dt. Now we can substitute the value for d phi and the value of dt here. Therefore E is equal to d phi value is phi m and dt value is 1 by 4f. Okay. So from this E is equal to 4f phi m. This is the average induced EMF value. E is equal to 4f phi m. Okay. So as we have given the AC supply in the primary winding, we need to find the RMS value. So to find the RMS value, we are having the formula form factor is equal to RMS value divided by average value. Okay, we are using sinusoidal waveform, therefore we are having the form factor value is 1.11, which is equal to RMS value divided by average value. From this we can get the RMS value. Therefore, RMS value is equal to 1.11 into average induced EMF value. Okay. Now we can substitute the value here. RMS value of induced EMF, that is equal to 1.11 into average value. What is average value of induced EMF? 4F phi m, right? 4F phi m. Therefore, 4.44 F phi m. And now, since we are having the primary winding and the secondary winding, we need to know the induced EMF on primary winding and induced EMF value on secondary winding. So induced EMF value on primary winding is denoted as E1, which is equal to 4.44 F phi m into, since it is induced EMF in primary winding, we have the number of turns in primary winding is N1 into N1. Okay, and now induced EMF in the secondary side, we can write it as 4.44 F phi m into number of turns in the secondary winding N2. Okay, these are the two values of induced EMF for primary winding and the secondary winding. So now we have the formula for maximum flux, that is phi m is equal to Bm into A. Bm is maximum flux density and A is cross-sectional area. Now we can substitute the value of maximum flux here. Therefore, we will get E1 is equal to 4.44 F B M A N1. E2 is equal to 4.44 F B M into A N2. This is the induced EMF value for primary winding and the secondary winding. Thank you.